Hello, good morning to everybody. Uh, Thank you, Professor Guthrie, to be here to give this talk. For me, it's a great pleasure to be today. Why? Because it's the first IQS-Cambridge talks that is an initiative of the IQS, School of Management to bring to IQS extraordinary university professors, researchers, to talk about something that matters, not only for us, but also for our world. And it was incredible that Professor, you'll be professor in just 2 months or something like that. Yeah. Professor Comim, I think, convinced Peter to be here, to be the first speaker. As Professor Comim will explain in brief minutes, Professor Guthrie is a reference in something that we should be experts at IQS, is the relation between engineering and sustainability. And yesterday, when we dinner together, we explained how important would be having this engineering focus on the big problems that we have as human beings. I expect that you enjoy this talk, but also you can feel that IQS matters of sustainability, and you can feel also that IQS is doing research and IQS is thinking on how to solve this problem. And Peter, I think that it's difficult to follow your path. You are very, very long from us, but I hope that you can inspire us, the old ones, and also the a lot number of students that they are willing to hear you. Thank you, Peter, again.
Now, good morning. I have a tough job here because I have to convey to you the CV of Professor Peter Guthrie, and that's not an easy task. So I struggled with so much he has done in the past, and I tried to organize my ideas, but I want first to apologize to Professor Guthrie if I'm not able to put everything, because it's really an impressive CV. So let me start from the beginning. He's a civil and geotechnical engineer, and his first job after graduation was in northern Nigeria. So before he became the first professor in engineering for sustainable development in the UK, this back in 2000, he was famous already. He had an OBE, which is a title of distinction, which is the Order of the British Empire, if I'm getting that right, in 1994. And he had done several projects in an amazing number of countries. So just for you to have an idea, he has been working in projects in Nigeria, Lesotho, Sudan, Philippines, Ethiopia, Botswana, not to mention some major infrastructure projects such as the London 2012, the Orange County Great Park, and that was in California, the Channel Tunnel Rail Link, Crossrail, West Coast Main Line, route modernization, Birmingham, Liverpool and Manchester airports as well, and another major building project. So like the Eden Project Phase 4, and I know that for you they might be just names of projects, but it's a very rich and diverse collection of projects, which on top of that he has also worked in large-scale schemes for the prison service and the Ministry of Defense. He has also advised on policy matters related to waste and environment in Russia, Mauritius, Seychelles, Romania, and Portugal. Now, one initiative for this professional life that is really remarkable, is really amazing, is that together with his wife, and she's here, Lorna, she's a little bit hidden over there, yeah, and they founded back in 1980, after Peter had an experience working with the United Nations in Malaysia and having to work with Vietnamese boat people. He was involved in the foundation of a charity called Red R that provides engineers and other personnel to relief agencies in disasters. I understand that these days they are more about capacity building and training, so they're not deploying people to those places as they did in the first place, but it's a remarkable initiative, and I invite you, Red R, to check on the website as well. So he was the director for the Center for Sustainable Development in Cambridge for 16 years, from 2000 to 2016. He has now retired as director of the center, but he continues to work on several research projects. So just to give an idea, his research is focused on the assessment of large-scale projects for sustainability, resilience of infrastructure, and energy efficiency in buildings. And work has included consideration of mixed developments, mining projects, housing, health, educational buildings in the UK. Well, another very important thing to say, he's an emeritus fellow of a very dear college in Cambridge, St. Edmund's College. And here, just to give an idea, I'm just going to talk about names because you're here to listen to Peter. But he has worked on so many projects on resilience and infrastructure, like the Lloyd's Register Foundation and ARUP, or then another project funded by a program of energy efficiency in buildings in China, or other projects for the Federation of International Consulting Engineers, Retrofit 2050 project, Project Butterfly, a wonderful project with 50 NHS hospitals in England as well in terms of developing energy efficient measures. And then, by the way, around 70 PhDs he has supervised in his life. He was vice-chair of DEFRA's Scientific Advisory Board, and he led the waste subgroup. He was also on the DEC project board for the Southern Tidal Power Scheme study. He has also chaired the Global Agenda Council on Disaster Management for the World Economic Forum. He was a member of the Catastrophic Risks. Now, the impression one has is that every time one needed to do something, they were asking Peter to join. It's really amazing. I'm not going to read more here, but just to mention that he was vice president of the Institution of Civil Engineers in the late 1990s. He has also, and he's also a fellow of the Royal Academy of Engineering. So I was doing my research, I was just entering, what's the meaning? Because sometimes in his CV, these letters F, R, Eng appear. And then what they say is that the Royal Academy of Engineering, where he also served as vice president, is for, but only for fellows, is for those individuals who have made exceptional contributions to engineering, and is considered one of the highest honors for engineers in the UK. Now, there's much more to it, but I know that you are here. I just wanted to say that on a personal note, when I was a young fellow at St. Edmund's many, many years ago, there was excitement in college when they said, oh, Peter Guthrie is joining the college. He was bringing such an experience, such a knowledge about how to do things. And at that time, when people were talking about sustainability 25 years ago, bringing people who are actually not simply talking about sustainability, but had experience, had the ground experience in big projects, doing that was a terrible excitement. And his contribution to what Cambridge is today in terms of sustainability cannot even be measured. So it was amazing. So for us, and by saying so, I'm inviting Professor Guthrie. So saying so, I would say it's more than a privilege, Peter. It's an honor to have you here. So we are delighted, and thank you all for people to have come here as well. So what we are going to do is that he will have the time he wants, and after that we are going to come back and just to moderate some questions that you might have. So Peter, thank you so much. The floor is yours. Thank you.
Thank you. Perfect. Thank you very much, Director. Thank you very much, Flavio. I'm not sure that I entirely recognize that eulogy, and I'm not sure that what I'm about to say is going to live up to such a strong billing, but I want to talk about infrastructure. I'm a civil engineer. I know that none of you is necessarily a civil engineer, but am I not doing?
We have to switch on.
I'm on?
It is on, but one cannot. Yes. Yeah. You know, we tried so many times, and so that's what happens. So let's see. Let's change just the microphone, perhaps, to see whether this will make a difference.
Pull that out.
And we try that.
Yeah.
Yeah. Do you think this can be unplugged? No, this is difficult. This is different. Okay, so let's go to our plan C, whether that's possible. You know, you're not going to believe we tested that a couple of times. Hello, hello? Hello? It doesn't work somehow. So perhaps the problem is not with microphones, but the problem, well, we can always blame the engineers for that, yes. So, but, oh, yeah, yeah. Or perhaps if we have more of these microphones there, so perhaps if you could kindly bring another one, we could try different ones. Okay. You think we could have another one of these? Or you want to? Okay, managed to do something interesting here. Okay. Want to replace that or to see what happens? But this should be working. I don't know. Now, you can always carry on, and then we are going, we promise we are going to. The only problem is that we need a microphone for the translation. But you know what? If you want to, we start and we can carry on, hopefully when they bring that.
Are you able to hear me if I speak now? Is that okay? Right at the back? So nobody can escape? That's fine. So I'm now going to be fairly brief because I don't want to interrupt the opportunity or interfere with the opportunity for questions afterwards. Unfortunately, that doesn't work either. So.
Oh, no, it did.
It did? No, I pressed that.
Oh.
I'm giving up on technology.
No, it does. It does. I think it's only because you have to press it further. Yeah. So let's test it. So you have to. The thing if you. Is the one? No, not this one. The one on the bottom. Yeah. Sure.
Ready? Right. So I want to talk about infrastructure because it's the underpinning of society. We all rely on infrastructure, but we don't think very much about it. In Europe and the United States, in North America, generally, our infrastructure is aging. It's typically way beyond its design life, and we continue to rely on it. We need more new infrastructure, and we're now imposing the requirements of sustainable development on what we do. Not just on what new build we have, but also on the maintenance of our existing infrastructure. And what I want to end with is a redefinition of what we do about infrastructure in the context and with the requirements of sustainable development. I want to talk about why sustainable development has emerged and how well it's been adopted and how it can be delivered in infrastructure. We kind of know what infrastructure is. It's roads, it's power systems, it's tunneling, it's renewable energy generation. And I want to also think first, before we get into infrastructure, where does the concept of sustainable development come from? Because it's emerged in the last 40 years. The background thinking of sustainable development is much more ancient than that. It's right. Give this a whirl. Can anybody hear me? Oh. I hope I get that much applause for my lecture. Was it better without? It was, yeah. You want it on. Okay. Oh, because you need the translation. Sorry. I'm very sorry. I'm very sorry this is not being given. I'm very sorry this lecture isn't being given in Spanish or Catalan. It would have been so much easier. Obviously, the ancient civilizations knew about sustainable development because that's how they lived. They lasted for thousands of years. The ancient aboriginal civilizations in the great land masses of the world lasted for many centuries because they lived within their means. But in the 18th and 19th century, we had new thinkers coming forward, people like Malthus, who would be very concerned if he saw where we are today, because he said you can increase agricultural productivity incrementally, but population growth is exponential. And so he predicted that we would run out of resources, particularly food supply, within 100 years. And Jefferson, the third president of the United States, who incidentally doesn't mention that on his tombstone because he was a very diverse character, he said that a generation should leave unmet debts for future generations to be saddled with. And John Stuart Mill believed in a stable state economy. But in 1987, the World Commission on Environment and Development produced this report, Our Common Future, led by the inspirational Gro Harlem Brundtland, who had been Premier of Norway. And although the definition of sustainable development that's in that, which is meeting the needs of the current generation without compromising the ability of future generations to meet their needs, it came at a time when there was real concern about whether or not development, particularly of infrastructure, could take place, because a rising environmental consciousness was impeding the progress of large-scale infrastructure. So it's a difficult phrase, and because it has a certain level of confusion around it, around 500 definitions have been produced in the academic literature since 1987. And it's moved from the novel, I think when I started at Cambridge it was a relatively novel concept, to the overused. So now sustainable development is claimed by almost every corporation trying to enhance its reputation with the absolute minimum of change to their business model. And in infrastructure, the reinforcement of this idea that sustainable development was being produced not just to protect future generations, but also to enable development. There were a number of famous infrastructure projects in the UK, and I'm just going to use a couple to make the point. And this was one, the motorway, the M3 in Twyford Down, The idea was that the last piece linking this south coast to London motorway would go through a historic landscape. There was an opportunity for there to be a tunnel, there was an opportunity for it to go up by another route that wouldn't be so disruptive but much more expensive. But the eventual decision was made to make a 17-metre deep cutting through a historic landscape. And this met with immense public concern and protests. And the Newbury bypass, at roughly the same sort of time, also in the south part of the UK, it cost £74 million at the time to build, a third of which was protecting providing the security for delivering the project. It cost £5 million to police it, and there were 750 arrests. So in the context of this, sustainable development being the Venn diagram that's often used is economy, society, and environment. Some environmentalists were concerned that actually sustainable development was weakening their position on environmental protection because society and economy could, as it were, outvote the environmental concerns. And of course, through we had the Millennium Development Goals, which were very focused on social development in developing countries, and the Sustainable Development Goals followed them with 17 areas, one of which is, as you can see, is climate change, and the one that really concerns us is industry, innovation. And it's quite telling, maybe, that infrastructure doesn't get a goal on its own, and the assumption in the SDGs is that infrastructure is a necessary part of development and it needs to be provided. And there is less focus and determination in the infrastructure sector to think about sustainable development and the objectives and aims of sustainability with any kind of purity, if I may say. At the same time, as a result of the Rio Conference in 1992, the United Nations Framework Convention on Climate Change was set up, and you must have heard of the Conference of the Parties, COP, which happens regularly, and we have many different COPs where we have great enthusiasm. Paris 2015, where there was a rethinking about how we were going to get countries to make commitments around carbon emissions, and in Paris it was agreed that every country would set its own goals, and that seemed to be a great triumph because developing countries could take a different view to developed countries and so on, and it was regarded as a great success. And so UNFCCC continues to report, and they have said that reduction in global greenhouse gas emissions needed by 2030 is 43%. That's a 43% reduction. And so far, the reduction achieved is 2.6%. So there is a genuine failure to act on the imperatives that we already know are unavoidable. Climate change will be catastrophic if we don't reduce carbon emissions at the rate at which the UNFCCC sets. We're already at 1.5 degrees of average global near-surface temperature warming, and we're heading for 3%, which on the predictions leads to widespread failure of crops. In passing, we all rely on about 12 different varieties of grass for almost all of our food origin. And whilst when I was involved in the World Economic Forum on the Catastrophic Risks Global Agenda Council, the global risk reports in the 2010s tended to be quite short-term, and whatever was in the news tended to be at the top of the risk perception by the people who were canvassed, the world economic leaders. But more recent reports now show that the risks now, and this is a graph which shows along the x-axis the 2-year horizon for risk, and the y-axis is the 10-year horizon. So anything above the 45-degree line, the risk is worsening, and 5 of those worst risks are environmentally related. And they relate to things like extreme weather events, change in the Earth's systems, and these are now being recognized. If they're being recognized, that's a good thing. If they're being acted on, it's very difficult to detect. So against this role, against this background, infrastructure plays a supporting role. It's a means to an end, it's a necessary evil. We don't love it. It's underfunded. It's always poorly maintained. And it's famous in failure and anonymous in success. We all know when something goes wrong in our infrastructure, we pay no attention to it when it's working well. And when you don't have infrastructure, you can immediately identify why it's important. So the absence of infrastructure in countries like this shows that the need for it is very well understood. But when it's provided, it's ignored. Now, large infrastructure projects, which I've worked on for a number of years, rely or are characterized by compromise. There's always compromise, both in what's going to be delivered, when it's going to be delivered, and how it's going to be delivered. They're years in the making. The Channel Tunnel between France and England was conceived of more than 100 years before it was opened. There's a strong political risk. There's a political risk in 2 directions. One is that an elected party thinks that a long-term infrastructure project is a good idea, and it's opposed by the opposition, in which case it has a small chance of surviving an election. But the greater political risk, and I'll come to this later, is when all parties agree that it's a good idea, because that means that it's subject to almost no critical scrutiny. There are strong regulatory frameworks. You make irreversible commitments with infrastructure which can't be changed, and you're never very sure how it's going to turn out. Railway projects, airport terminals, bridges, roads in many different settings are all water transfer, large-scale water transfer schemes. They're all examples of large-scale infrastructure. Now, some projects have sustainability thrust upon them. They may not necessarily have thought that sustainability was their primary aim. But the Eden project in Cornwall, which is a visitor attraction with different biomes of different climate temperatures inside, was really thought of in terms of a regeneration project of an abandoned mine, but has developed a sustainability story which is very strong. The North of Scotland Hydroelectric Board, a complex array of hydroelectric schemes in northern Scotland, all developed in the early part of the 20th century, weren't thought of at all as sustainable in that kind of language, but they have become a very important part of the renewable energy strategy for Scotland. And the canal system in the UK, which was built just before the railways boom, was really a transport network with highly commercial ambitions in mind, but was almost immediately eclipsed by the railway network. But we now regard the canal network as a major visitor amenity. More recently, the Thames Tideway Tunnel, which was conceived of in London as a necessary response to the wastewater directive of the EU, involves a 7-metre diameter tunnel from the west to the east of London, with shafts up to 20 metres in diameter for the removal of combined stormwater and foul water. An alternative would have been, in the case of this project, to separate foul water, which is a very small percentage, and stormwater, which is the dominant one. But now what we're doing is, and this is paraded as a sustainable project, we're having to, because it's all run through London in the tunnel under gravity, it has to be pumped at the end up 80 metres vertically to the sewage treatment works, where it's over 90% stormwater, which doesn't need treatment, but it all has to be treated as far, and it has to be pumped 80 metres vertically forever as part of our drainage system in London. And the Olympic Park in London, although it's historic now, because it's 12, 13 years ago, one of the main reasons that London was awarded the Olympics over Paris was because the sustainable development requirements of the International Olympic Authority were more were more adhered to by the London bid than by the Paris bid. And so there was a very strong 12-point sustainability strategy, which, because it was a public project with a very definite timeline and very strong public scrutiny, actually adhered to most of its sustainability objectives. Very unusually, and because it was a unique project, I think it's probably very difficult to claim that it was in any sense a trailblazer for future projects, because most of the lessons learned from the project were not carried into conventional projects. And then when you have all-party agreement that a new project should go ahead, you end up with this terrible project in the UK. HS2 is a high-speed rail between London, well, it was conceived of a high-speed railway between London and Glasgow and Edinburgh via Birmingham on a Y going east and west. From the very early days, it was easy to identify that it failed to deliver on any of its key objectives. But because all parties agreed that it should go ahead, there was never a moment at which any politician was prepared to say, this is a ridiculous project. It has to have a spur to Birmingham. It doesn't go to the main station in Birmingham. It needs to have a spur to Heathrow, where one of the main demands is travel. It has to stop at a station outside London called Old Oak Common, which has been created on Crossrail, to be able to cope with the capacity, because Euston Station at the London terminal can't cope with the number of passengers predicted. And it's already produced 5 separate business cases to justify it, because the basis on which the whole project was conceived is flawed. And now it's going ahead, but only phase 1. And of course, a high-speed rail link between London and Birmingham is the ultimate irony, because London and Birmingham are far too close together for the high-speed advantages to be gained, because it takes so long for a high-speed train to reach its maximum speed and so long for it to slow down to stop. Now, typical project lifestyle is, and this is getting to the real nub of what I want to convey, is that we do an ex-ante assessment. So we do an assessment of a project at an early stage of its conception. And we almost invariably decide at that stage that if we are going to go ahead with this, if we say we will go ahead with this project, almost no project is ever cancelled after that point. So with highly inadequate and partial information, we make a decision to go when we don't know what the real consequences are. We ask, will it work? We can generally get that fairly right. Will it make money or not cost too much? We always get that wrong. We always over-predict how many people are going to travel. The number of people predicted on the high-speed link between London and Paris was overestimated by about 4 times. And that was done almost I would say knowingly, because without that patronage, it wasn't possible to justify the project. We ask whether it will damage or enhance the environment. Now we do that as a prediction, but to do the environmental assessment in advance of a project, we have to know enough about the project to be able to say what the impacts will be, which means that we have to design the project in immense detail. We have to know where the construction sites are going to be. We have to know how much material is going to be brought to site and how it's going to be brought to site. We have to know what materials are going to be used and so on. So we have to go to such a high level of detailed design that by the time we've assessed the impacts, it's practically impossible to change what we've decided. There's another big problem, and that's in baseline description. So the impact of a project is the difference between what will happen if we don't have a project and what will happen if we do have a project. And that's an impact on ecology, noise, dust, archaeology, social impact, and so on. If your baseline is unstable, it's not possible, it's not easy, in fact it's not possible, to say what the difference is between not having a project and having the project, because your baseline is shifting. And this is really poorly understood in the literature and in practice. So if your baseline is historically changing and you have an idea of which direction it's going in, you can then guess what the project might do, and you might propose that there could be some mitigation. But these are highly speculative. And you have to say which changes are likely to occur. There's a really good example in the southwest of the UK on the Severn tidal power. The River Severn has a tidal reach of 14 meters, so it's the second highest in the world. It could produce a huge amount of electricity, and if you design it right, it can be a 24-hour operation. This one scheme, the Cardiff to Western barrage, we looked at 7 different schemes, I think. But the one scheme, the Cardiff to Western, shown in dotted red there, between Cardiff and Western-super-Mare, could still produce 5% of the UK's electricity demand. And it would do so for 125 years, and that would be once it was constructed, it would be virtually carbon-free electricity. The great debate, and this is the environmental dilemma which is really crucial to so many projects, is we are, through the legislation and the way we operate with impact assessment, concentrated entirely on what is the environmental impact. So we talk about ecology, noise, and so on and so on. What about the natural environment? What would be the impact be on the natural environment? What are the local environmental impacts? And how do we, as I described before, how do we cope with that changing baseline? But if we worried about climate change mitigation and carbon reduction, we would say if we can produce 5%, as we did in this case, 5% of the UK's electricity from a single project which has no carbon emission, effectively no carbon emissions once it's constructed, and it will be working for 125 years, with replacement of the turbines after only 45 years. If we could reduce carbon emissions that radically on a single project and address those global environmental concerns of mitigation, is that more or less desirable than local environmental changes? One of the big things on the estuary, because it's mudflats, was that there would be a change in the populations and species of wading birds that would operate in a mudflat environment that was going to be flooded for longer periods in each 24-hour cycle. And there's no simple answer to that dilemma. Do we prioritize local environmental concerns over climate change, or climate change mitigation over local environmental impacts? So at the moment, we identify a project. Sometimes it's an obvious need. There's a need to complete a motorway network which has a missing link. Sometimes it's a demand for additional power, and so we need additional, now mostly renewable energy sources. We can do the economic feasibility relatively easily, although we generally are deceiving about what the benefits are likely to be, what the patronage is likely to be. We can make guesses at the social acceptability. In general, large infrastructure projects are publicly financed, and so government has a responsibility which they take with gay abandon generally. I'm not sure that they're particularly concerned about that dimension because it's in the public good, and almost all infrastructure produces a cost-benefit ratio above 1. And then we go into detailed design. There will be headline environmental issues in that process, and there will be some social environmental protection built in. But value engineering always comes into play, which means that you cut out all of those dimensions of a project which are not completely essential to its operation. And a lot of features which were thought of at the beginning or sustainable are eliminated at that stage. And commitments made in the environmental statement and the environmental assessment are often not built into contractual obligations. This is clearly a broken system if we're serious about sustainable development. If sustainable development really, and we really wanted to achieve it, we would set the goals of sustainable development for a country or a region as the guiding principle. The infrastructure needs would be identified in that context, and there would be environmental constraints and social constraints and social opportunities identified, and the engineering options would then emerge from the strategy that was set by sustainable development principles. It's the inverse of what we currently do. We currently choose, we'll have a railway, we'll design the railway, we'll worry about the environmental impacts after everything has been fixed, so we can't do anything about them. It's a mendacious, cynical way of delivering infrastructure against a script of sustainability, which is no more than a veneer. The change is needed because we have increasing complexity in our infrastructure. In the UK, I don't know about here, but I do know that in the UK we've privatized much of our infrastructure, and it's turning out to have been an absolutely insane decision. We've effectively renationalized half of our railway system because private enterprise has failed to deliver service. We're in the process of, we're very close to renationalizing Thames Water, the largest water utility in the UK, although it's just been rescued for another 5 weeks. And because we've committed a lot of our infrastructure to private enterprise, they have driven towards increasing efficiency, which automatically decreases resilience. There's increasing pressure on all of our infrastructure, and there's a declining competence. Again, I only know about the UK. There's a declining competence in government. Because we're stripping out most of our civil servants with technical capability, the ability of government to be critical and to write competent contracts for provision of services is diminishing. There's very poorly understood interdependency of the systems, and we talk about systems of systems, but we don't really do anything constructive to deliver on it. And our aging infrastructure is rapidly reaching the end of its life. So in closing, I want to talk a little bit, because this has all been about civil engineering, and not all of you none of you are civil engineers, but the engineer's role is very important. Engineers are drawn to being engineers because they enjoy convergence, they enjoy detail, they enjoy definition and clarity, and they are often uncomfortable with uncertainty, fuzziness, a wide variety of options to be expressed, and inventiveness. Of course, there's huge creativity in engineering, but it's within a scientifically traditional framework. But if sustainable development of infrastructure is going to be realized, engineers need to operate at the very earliest stages of decision making. They're not nearly near enough the seat of power. Engineers, particularly in the UK, are very rarely seen in the political arena. But only engineers can combine function, consequence, and context. As engineers, we have a professional duty to expand our role and increase our influence. And that means that we have an obligation to teach engineers differently. Engineers have to be given a broader spectrum of training and education in their formation to be able to take their place at the decision-making table particularly around infrastructure. What it is to be an engineer needs to change. Redesigned education and qualification of engineers is necessary. There needs to be a recognition of this new order. And time is, unfortunately now, not on our side for the scale of change that's required. Thank you. Thank you.
Now, thank you so much. We have some time for questions now, so hopefully this microphone will work slightly better. We don't know whether... Let's see. Oh yeah, it's working. Thank you so much, Marcel. And just to allow you some seconds to formulate your questions, should you have any. I would like to put one question because I have many questions, but I chose one only because I found fascinating what you have said about efficiency, the trade-offs between efficiency and resilience, because I think some of these issues that you mentioned to civil engineers, I think they all apply to all of us. I can see Jordi Diaz, my colleague, the dean of the engineering school here, and all these qualities would apply and want to do the same thing at the School of Management. And then we always pray for the God of efficiency. So, but if you could elaborate just a little bit about this trade-off between efficiency and resilience, I would be grateful just with an illustration perhaps.
Yes, we did some work on resilience of infrastructure around the world, and one of the places we went to was Christchurch in New Zealand to look at the experiences after the earthquake there in 2010. And all of the public utilities there all said, now that we have had this earthquake which disrupted telecoms, foul water, water supply, roads and so on, we now have to rethink the way in which we deliver public services through infrastructure. So the telecoms people said, we used to work on 99% on connection, so that our customers would rely on us for 99%. That's no longer good enough, because in the event of a disaster like an earthquake, that's likely to be when the 1% of failure occurs. And that's the one time you absolutely need the telecoms to be working. So they now completely changed their strategy to 100%, which has involved a huge amount of building redundancy into their system. Most electrical systems have ring circuits where they have two-way supply, so that if there's a cut in any system, they can still get to supply the customers via the other route. Increasingly, that's becoming rarer because developers are not paying for that additional redundancy. The same is true if you look at New Zealand. They're waiting for what they call AF8, which is an earthquake down the western side of South Island. They know it's coming, they know it's a major fault, they know it'll disrupt all the roads feeding from east to west across South Island, and yet they have no plan for how to reach those communities on the west. They don't have, the obvious would be to come in via shipping. They have no plan for providing those towns by shipping yet. They're conscious that they haven't done it yet, but it's that kind of, you need that additional layer of planning to improve resilience in your systems, and it's very complicated and it's very new for most infrastructure providers.
Very good, thank you so much. Now, questions, don't be shy, please. You have only, yeah, I can see Ophelia here. Yeah, I can see 3 hands here, so don't worry. Yeah, we are getting there. If you wish just to introduce yourself very briefly.
Hello, Professor Guthrie. My name is Ophelia Kranicki. I'm a first-year student here at IQS in International Business. I'm from the United States. And I have a question. How would you consider ethics regarding the implementation of sustainable infrastructure designs?
Well, in a sense, what I was describing was an ethical approach, which I think is largely absent from what's being delivered at the moment. I think people who work honestly, and I think they think they're working within an ethical framework, but as a system, the system is declining to adopt the sustainable development imperatives that I was declaring. And on HS2, I know I go on about HS2, I'm obsessed, but I never spoke to a single person working on HS2 that thought it was a good project. And there were hundreds and hundreds and thousands of engineers working on it. Nobody thought that it was a defensible project. But because it was so huge, I mean, it's running at, I can't remember what the latest spend is, I think it's 35 billion. But it was going to be 130 billion if they'd finished it. Everybody knew that the industry was really being propped up by such a huge project. And there's a conflict that people knew that they were working on something that was indefensible, and yet they didn't feel that it was a moment when they could choose to withdraw.
Yes, thank you so much, Professor Guthrie. That was truly inspiring for us. I'm Cristina Alonso, and I head the Center of Research for the Jesuit Universities in Spain, out of here, IQS, just recently created last year, and I'm looking forward to making a difference with all the colleagues here. And my question could be, in your opinion, how could we increase the understanding of the meaning of natural capital with the new generations, also with the previous ones, but maybe especially if we want to influence with the new generations? Because my feeling is that we quite understand what financial capitals mean, but we are making a huge mistake by not understanding the essential importance of natural capital. Thank you.
Yeah, I think it's a very good question, and I think natural capital has been around a long time in the academic understanding, and yet it has not really found its way into the decision-making process, because I think that there's a sort of obsession. I don't want to be rude about economists, but if you can't measure it and you can't monetize it, it's very difficult to include it in your decision-making. And yet, natural capital, when we've attempted to do something with natural capital, we've done something around ecosystem services, which to me is intellectually weak. If we're only relying on ecosystems in terms of how they deliver for us as human society, I think we're missing the point of a natural system which is in and of itself immensely valuable, but almost unquantifiable. And so we have to rely on something much more vague. This is why I think engineers need retraining. They need to be able to articulate what it is to value, to include in your decision making something that has no monetary value. You could say, I think some things in nature are binary. If we don't have that, it is so catastrophic. There's no point in trying to value it, because we must protect it. If we must protect it, the cost of protecting it is what it is. It's not a shall we try and reduce that cost a bit, or shall we hope that it doesn't eventuate as we fear. We just have to say there are and we've got plenty of science around natural capital. There are lines that we are crossing about capacity of systems that we know are breaking, and we're still not making decisions to defend them or reverse the process.
Okay. First of all, thanks for the talk. I thought it was very interesting. I am Raul. I'm a professor, lecturer here at the Department of Chemical Engineering, and I actually work in process system engineering combined with life cycle assessment and environmental assessment, so quite familiar with all these things. Many questions I would like to ask, but I will try to keep it brief. Just a couple of them, kind of interconnected. First of all, you mentioned that, kind of the examples you were given, and especially given your background that you have worked in many kinds of different projects, big, small, more local, more global. All of them, the amount of investment will depend on their scale, and take into account this environmental aspect or this sustainability aspect. From your experience, you would say it's better to handle these projects from a local perspective or more a global or national or larger scale perspective?
I think local. It has to be local, and then you have to fix what's wrong with what happens when you allow these decisions to be made at local level, and there is a level of disinformation or corruption, or things can go wrong, and you understand that. But I think you can't take away the sovereignty of local decision making. What you need to do is to be able to help local communities contextualize the decisions that they make. So they have to be able to understand they sit in a wider system, so just concentrating on what they want for themselves has to be balanced. If you can persuade them to balance with what they want locally, with what fits regionally, nationally, internationally. But I think we've got a long history of colonial imposition of decision making. I come from a very successful colonial country, which has got a lot to answer for. But we've messed it up, and now we need to reverse that process and make sure that localization happens in a properly informed way. And there's many dimensions to that. We have to be very, very careful that we're not stripping out from countries needing to make these decisions all of their best talent because they can earn money in the Western economies that it dwarfs what they can earn locally. That's just a small cameo of what's going wrong at the moment. But yes, I think locally, start with local and work your way backwards.
Okay. There's a question there.
Okay.
You have another
just
one.
A very small,
Yeah,
very
please.
short one. Last one, I promise. So, actually, on that regard, since the whole talk at the end of the day was about the role of infrastructure regarding sustainability, development, basically, would you say that projects or infrastructure that is their main focus is actually sustainability should be prioritized? For example, direct air capture that you may be familiar with.
Yeah, sustainability should if you can get your sustainable development policy to be articulate and comprehensive, it should be the starting point of every decision.
Okay, thank you very much.
Very good. I think I saw Roberto over there.
Thank you. Roberto Cantoni, IQS as well. I have a couple of questions. So first of all, thanks for your talk. And so my first question would be, you were mentioning, when talking about natural capital, how to bring in the cost-benefit analysis, something that is very difficult to commensurate, and that to me sounds like a bit like squaring the circle in a sense, because it's bringing the incommensurable into commensurable. So I have no solution to this, but sometimes I'm thinking that when the kind of techno-economic rationale comes in and starts interacting with some other kind of, how to call it, some kind of other kind of worldview that is not necessarily techno-economically based, then that's where the interaction and when the discourse breaks down. At some point, the discourses, the metaphysics are so different that there's no way that these two sides or multiple sides can communicate. And I still wonder, since the 1970s, as you know, there's been also a lot of talk about descaling or descaling to local kind of infrastructure, especially with renewable energy infrastructures, also to make it, in a sense, more to improve the governance of those systems. It's been talking about convivial technologies or soft energy paths. So what's your position vis-a-vis this part, which is going to be kind of follow up on the previous question. So what's the role? What would the role of small technologies be with respect to these kind of large-scale technologies?
Yeah, I think there are certain areas of infrastructure where you can do local and it works really well. I think energy generation and consumption is a really strong candidate for that, because the resistance to renewable energy generation, particularly on land and actually offshore wind turbines, is very strong, because the connection between generating and consumption is broken. There's generally not much of a relationship. So in that respect, I think local decision making is a really strong basis. I think transport in cities probably, but intercity transport, it's a national strategy. You can't make these decisions locally. Otherwise, you end up with a sort of balkanized society, which is really almost unmanageable. So I think you have to recognise that infrastructure is an integrator in society and can be a very strong integrator. But so I think it depends which sector you're talking about. On the techno-economic versus the more unmeasured, as it were, or value-based decision making, I think that's the point I think I was trying to make, which is that engineers need to be attracted to become engineers and be trained to be much more open-minded and divergent in their thinking, rather than being looked to as the technologists to provide the answer to the question that is set by others. Because if you only answer the question you were asked, the ethical basis on which that question was set is not your responsibility, and it's wrong. And that's why we end up with some of these ridiculous projects, because the engineers have come in late, they feel themselves not empowered, or in fact not heard to make any sort of criticism, and maybe intuitively they don't have enough of the education and training to operate in that environment. I think it's a fundamental shift.
That applies to all of us. So so there are other two questions here, please, and especially ours. Okay, so if you kindly allow, on the way the microphone here. So terribly sorry. Yeah, not good for sustainability at all. But anyway, please.
Well, sorry. I'm Victoria from the first year of marketing, and I'm from Ukraine. So I think we all know what's going on, and that some cities they're completely destroyed. And I would like to know if you have studied the situation, and if you know how many years we will need to build it again, to make new sustainable, infrastructure, and that's my question.
It's a really good question, and I think the very disillusioning answer to your question is that it's a very long time. Take Christchurch as a small example. It's a small city of 300,000 people. It was a very big earthquake, but it didn't do as much damage as you might imagine, nothing like a war. And 14 years later, the reconstruction is not complete. There are still some buildings which just have fencing around them saying do not enter, and because they were damaged beyond repair. If you look at Syria, Gaza, Ukraine, the reconstruction effort required in those cities is really complex. Just the clearing of munitions and mines from those cities will be a major task. And so there needs to be, for hope, there needs to be a strategy which develops a deliverable program on a localized area, so that you deal with small areas and complete them rather than trying to go in and sort of work everywhere you can, because that feels like you need, it's not efficient. You need to deal with it almost street by street and building by building. And yes, it's going to take a very long time. I'm sorry.
Please.
Thank you for the very interesting talk. I really enjoyed it. My name is Ibuki Kusano. I'm a professor in the industrial engineering department. And you just mentioned wind turbines a while ago, and I work with wind energy. And you know that many of early built wind turbines, offshore wind farms, will come to end of design life by 2030, right? And then now we are faced with this huge problem: what to do with this, man-made structure, in the middle of the ocean. And there are several options. You do either decommissioning or repowering or partial repowering, and there are different options. But I think it's a bit ironic that in order to comply with this sustainability requirement, we are building these huge man-made structures in the middle of the ocean, and now we are facing with this problem, right? That what to do with this huge waste from this offshore wind farm. Do you have any thoughts on this?
Well, I'm not an expert, so my thoughts are just passing opinions. But what is scandalous is that nobody at the beginning of the wind turbine generation thought, wouldn't it be a good idea if the blades of the wind turbines were recyclable? And they're not. So we're going to have huge graveyards of these monstrous turbine blades, which are just not recyclable. In a way, for me, that's a greater problem than the subsea structures, which are reusable. And as long as you can manage the corrosion process, which I think is relatively straightforward, I think either leaving them in place and using them for future turbines, and maybe requiring that new turbines, which are going to be put in the sea, are designed so they can take larger structures than is currently being designed for. That's not happening either. So a little bit of forward thinking, a little bit of sitting around and just thinking about the what ifs, rather than just saying we have a design life of 35 years, we have a requirement to deliver on this, this is the economics of this turbine and so on. I think we just need to be thinking much more holistically about the process. You have to do life cycle analysis, but the life cycle analysis often includes some, imagination or hope associated with end of life. And the idea that you discount the carbon associated with recovering materials from end of life feels to me like you're banking on something that you can't rely on. I think that should be discounted as part of the calculation.
Thank you for the talk. I have two questions. They are somehow related. The first one is more general or wider. It concerns the general principles of justice. You mentioned a dilemma that civil engineers sometimes face, which is when you have a budget and you have two projects, and one addresses global challenges and the other one local challenges, both related to the environment, it's a hard choice. That's what you said. I think it shouldn't be, at least when rich countries are involved. And let me explain you why it shouldn't be a hard choice. If we apply principles of justice, Rawlsian way, okay, or something closer, Scanlon, whatever, principles of justice, of course, in that kind of tradition, when we apply this principle of justice, taking into account the whole humanity, it seems that if we negotiate under the veil of ignorance, but knowing that some countries are rich, and those countries are rich because they pollute it more than others, it seems that when there is a project or a choice in a rich country between global trouble and local trouble, it seems that rich countries should go for the global one out of these principles of justice. And I wanted to know if, according to your experience, I know that it's very difficult to correct something we said in a talk, but now that I'm presenting to you this objection, whether you, a civil engineer with highly ethical standards, would agree on that with me or not.
Did you say there were two questions?
Yeah, that's the first one. Because
no,
yeah.
I'll answer because I can't ever remember this first question. Yes, I do agree. I think the global answer is the one that you should choose. In the case of the 7 tidal study, what we knew was that there used to be, I can't remember the bird types now, I think they were Dunlin, and then we thought 30 years ago they weren't Dunlin and they were something else, and now they're Dunlin, and we think that in another 30 years it'll be something else. So if we put in a barrage, there will still be mudflats every 12 hours, but we don't know whether they'll be Dunlin or whether they'll be something else. But we know that there will be wildlife. We're not covering it in concrete. We're just changing the let's call it natural environment, and there will be an ecology that is built around that, but it isn't the ecology that we have now. That strikes me as a small price to pay compared to the mitigation of 5% of carbon emissions. So yes, I definitely
Okay.
But there's another side to that is, why do we think we can continue to demand the level of consumption of electricity that we currently have when we make almost no effort to reduce demand?
I do not have the answer, but I'm concerned. The second question, maybe related to this challenge. So the first one was posed as, my condition of business ethics professor, and the second one, I'm a practicing lawyer. I'm working in IPCM projects myself, not FIDIC, because FIDIC means a lot of money, so that's out of my league, but more mothers. But I'm used to work with civil engineers who actually are project managers, okay? And honestly, these last few years in the chemical rack in Tarragona, I realized that there is a true concern for sustainability, especially in the design phase. Companies, governments, and engineers really struggle to meet these demands in an honest manner. That's what I saw, what I've been seeing in my practice. However, things radically change, okay, and I understand that your point insisting that it's crucial that sustainability issues are thought and they are very well taken care in the design phase. So even when this is done, okay, and rightly done, when the project starts, when all the relevant contracts are signed, okay, it seems to me that the only thing project managers care is to complete the project in the time for completion. And though in the contracts there are nice wording related to mitigating costs, trying to rationalize resources, even take into account environment, those clauses are never executed. Or in my experience, I've never executed one of these clauses, okay? It seems that all that matters is to get the project done in time. And the problem is that if that's the objective, if we cannot move the time for completion, in terms of the environment or sustainability issues, lots of resources are waste. And I see this as a lawyer, and I was thinking, because obviously your experience here is enormous, how can we address this in not FIDIC projects, but even small projects? Because if you add them up, the problem is huge.
Yes, I completely agree. I think I did mention that environmental commitments made in the environmental assumptions made in the environmental statement often don't find their way into contractual commitments. So if you don't make it a contractual commitment, the project manager will say, what am I measured on? How much is it costing me? If I run late, it costs me £100,000 a week. If I ignore the bat protection, it costs me nothing. Or it might cost me £5,000 for a fine from the Environment Agency, but who cares? So the only way to change that is to change the contractual framework to be much more militant and dictatorial around those commitments that are made, on the basis of which a decision has been made to go ahead with the project. I spent time a while ago with the sustainability manager of a large oil company. I can't name it, but it sounded like Shell. And she was very committed to sustainability and had a fantastic policy. And we used to have very good conversations with her and her board member and so on. And then one day I had the opportunity to have a conversation with her by herself. And I said, how is it really being, a sustainability manager of Shell? That's a tough gig. And she said, I write these great policies, and then I go to an oil facility, an extraction facility, and I say, what do you feel about this sustainability policy? And they say, look at what I get measured on, and none of it includes sustainability. So, it's nice to see you, but good night.
Now, we have to come to a close, but we have two questions. So I'm going to ask people to be brief in their questions so we can close our session. So please, first here.
Yes, it was a bit related with the previous one. So, like time as a key point to manage, and I think if we could act like water engineers and to measure which is the cost in 50 years for floods, etc., and for 100 years, etc., and we can put it into the design of things, maybe we will be able to think systematically and through contracts. And so I won't explain more because I think you answered a bit, so I wanted to be brief, but I think this is a key point. So how can we change culturally and incorporate time into the design and into the decision making, and not trying to say, okay, I will drink another beer, because as if time would not exist, because time exists, and if you are drinking a beer every 5 minutes, you will be dead quite soon.
I'm not quite sure I get the full drift of the question, but one of the things that you can change around time is to change the social discount rate. So the reason that the 7 tidal power scheme was rejected by government was because all of the benefits associated with that scheme beyond 15 years out from now, from when it was finished, are practically zero at a discount rate of 3.5%. If you had a social discount rate of 1%, then that whole benefit of 125 years of delivery would make the scheme absolutely the right thing to go for right now with all known technology. So the discount rate, again, I'm blaming economists, but the discount rate kills projects which have long-term projected future benefits, because the net present value of those benefits is discounted practically to zero.
Yeah, so we go to the last question now. Merce, please, is over there. She's over there. Yes.
Hello, my name is Astrid. I'm the technical manager at Gas N2. We're a company, we build industrial machinery in the field of gas consumption. My question is in the same topic. We have seen the 2 last ones. I really like the part of your ex-ante assessment of the environmental impact of projects, and of course, especially in private sector, the timings and the rush to implement projects is a struggle, a daily struggle. So my question, or if you have a tip for smaller companies, is how do you engage, let's say, non-believer colleagues into doing this analysis at the very beginning, where you can implement measures that have an impact in the future, and not just wait and we will see later, because then probably you cannot implement anything.
Yeah, I think of course it's extremely difficult, otherwise we would be doing it. But I think the use of examples where that has been possible, if you actually look at some historical projects where there was almost a disregard for the initial capital cost because they were building for what they might have seen almost as permanence, you can demonstrate that the facility has existed for much longer than would have been expected. So the Thames Tideway project in London is replacing sewers that were built by a man called Basil Jett in the late 1800s. And London has been relying on those brick-built sewers for 140 years, completely beyond what was projected for them. So I think if you can refer to some examples where an increased level of awareness of the benefits associated with maybe more resilience, more sustainability, more endurability, it might influence some people. But in general, the accountants and the financial decision makers are pretty inflexible.
Okay, so thank you so much. We are coming to the end of the session, so I want to mention just that I think this is a memorable session. I think not simply because of the contents, the things we have discussed here. I think, Peter, if I may, I could say that a magic has been produced here at IQS, because you managed to engage people from the two schools, so we have a conversation here today. I can see professors from two schools. I don't remember many of this kind, so I think it's extremely important. But also I think the word that comes to my mind would be authoritative. Everything we heard here was extremely authoritative. He has been there, he has done that. So, and I think it's a lot of food for thought for us to think about how also to have impact. That's an important word for us in the real world. So I'm sure you want to just express once again our gratitude to Professor Guthrie. Thank you so very much.
Thank you.
Then I broke a glass. What?